All right, so for number 5 on the review, we don't have to graph all these functions, we're just asked about end behavior. So having a sketch in mind is helpful. So I'm going to do some little sketches here to help us out. So for A, log, starting off with this tricky one. We have log of x minus 9. So the minus 9 is going to move our function right 9 units. So that's going to make our log function look like this. There's x equals 9, and then log is going to go off this way. So remember with log, we're looking at two directions here. We're looking at as we approach the asymptote and as we go to infinity. So as we approach the asymptote, as x approaches, here we're approaching 9, and we're approaching from the right, y is going to negative infinity. It's going down forever. And then the other way is a little easier. As x approaches infinity, as x is getting really, really big, we're going out faster than we're going up, but we're still going up forever. So as x is approaching infinity, y is approaching infinity as well. Okay, B, negative x squared. I like this one a lot. Negative x squared, that's just a reflection over the x-axis. That means this is a down problem. So as x approaches negative infinity, y approaches negative infinity. And as x gets really, really big, as x approaches positive infinity, y is going to negative infinity as well. It's down, down, going to negative infinity, going to negative infinity. Awesome. Okay, square root function. The 1/5 on the inside is a horizontal stretch by 5. And up 3, that just means it's going to go out faster than it's going up, and we're moved up 3. So it's going to look something like that. We can only assess end behavior in one direction as x approaches infinity. As x approaches positive infinity, y is going to approach positive infinity as well. Again, this is another example where it's going out faster than it's going up, but it's still going up, still increasing. Careful with this e to the x. This is a little bit tricky. So 5e to the negative x. The thing that really affects our end behavior on this one is the negative of there. So usually e to the x looks like this. It's an increasing function. But when we flip that over the y-axis, then it's going to look, I have to think hard on this one, like this, if we reflect it over the y-axis. So we've reflected it. Now this guy is what we're going to use to do our end behavior. This is also a vertical stretch by 5. That just means it's going to go up faster than normal. So the end behavior is going to be the same as this guy. This little pattern down here is what we need. So as x approaches negative infinity, y, here out here, we're going up, up, up as x is going negative. So y approaches positive infinity. As x approaches positive infinity, y is going to 0. Remember, we have that horizontal asymptote anytime we're dealing with e to the x. That guy is important. Okay, cube root. Cube root, it's moved over and moved up. So right 5, up 6. Still going to look like that. Now this guy looks like it flattens out. It looks like it might have a horizontal asymptote, but it doesn't. It's really going down forever over here. It's just going out faster than it's going down. And it's really going up forever over here. It's just going out faster than it's going up. So as x approaches negative infinity, y approaches negative infinity. And as x approaches positive infinity, y approaches positive. One more equation, and then we're going to look at some pictures. 1 over x plus 2, 1 over x, and then the plus 2, we're just move 2 units to the left. And 1 over x looks something like this. Again, you don't have to do these sketches. You don't have to do them specifically. If the parent function is all you need, that's fine. I'm just trying to give you as much as I can to make this easy for you. So both in the positive direction and in the negative direction, we're evening out to 0. So as x approaches negative infinity, y approaches 0, that horizontal asymptote. As x approaches positive infinity, y approaches 0. You want to look for those horizontal asymptotes. Horizontal asymptotes, by definition, go with behavior. Okay, 3 quick graphs. So it's helpful to identify the parent function that goes with the graph, I think, although it's not 100% necessary. G is a cube root function. You can absolutely write up some transformations that go with that if you'd like to. I'd love to check them in class for you. Here, as x gets smaller, y is getting bigger. And as x gets bigger, y is getting smaller. This is a reflected cube root. So the end behavior is backwards from the parent function. It's a decreasing function. As x approaches negative infinity, y approaches infinity. And as x approaches positive infinity, y approaches negative infinity. This next one is e to the x flipped over and moved around. So here, we're evening out to 6. And on the test, I think on a problem like this, it would be nice to give you that dotted line there to show you the asymptote. So as x approaches negative infinity, our function is evening out to 6. Approaching that horizontal asymptote at y equals 6. And as x approaches positive infinity, y is getting small, small, small. Y approaches negative infinity. Last one. This guy is 1 over x squared. And it, again, is going to have an asymptote here. So in both directions, as x gets really small and really big, y is going to 2. Awesome. Please come see me if you have any additional questions about end behavior or anything else on the review. I hope that was